So quickly, this picture shows that we have things that can be considered one dimension. We have things that are considered two-dimensional. And sometimes we see that that's just 2D. And then we also have things that are three-dimensional, where we then say 3D. And we really live in a three-dimensional world anyway, so that's what we're most used to thinking about. And so we can see that if we're talking about one dimension, we really just have length. And with two dimensions, we usually have length and a width. And finally, with three dimensions, we continue to have length, width, but this time then we also have the height of our figure. And our focus is volume, and volume is always when we're talking about 3D objects. Okay, so volume is always with 3 dimensions. So when we look at a three-dimensional figure, and we'll start with rectangular prisms, the idea here is that you really just want to find the area of the base, or the red section in this prism, and then figure out how many layers of that base can you build within the rectangular prism, or to the same height as we know our prism to be. So as a reminder, this here would be our length, our width, and our height. And so remember from the previous video, we mentioned that volume actually gave us length multiplied by width multiplied by height, but sometimes you see this as being big B multiplied by height. And that big B represents the area of the base. So if we have our base layer, we find the area of that base, and then we can multiply by the height, because then we know that we would have that number of layers in our three-dimensional figure. Let's start with figure A and just simply determine how many cubes are going to fit in this prism. So we could stand or sit here and count them all, and keep in mind that there are some that we can't see, or we can maybe be a little bit smarter about it and determine how many cubes are going to be in this base layer. So I'll stick with the red. And so if this here was my base layer, I know that I have 1, 2, 3 by 1, 2. So that base area is going to give me 3 times 2, or big B would equal 6. And that's going to simply be 6 units squared. And from there we can figure out how many layers do we have. So here's another layer, another layer, another layer, another layer, another layer, and our last layer. So we don't have to worry about the top that I didn't do anything with, because that's really just that top layer of my last blue line. So in total, don't forget to count the bottom layer. So that's 1, 2, 3, 4, 5, 6, 7 as my height. So height equals 7 units. To find the total volume then, or to count the number of blocks we would have, there were 6 cubes or blocks in the bottom layer, and I know that I have 7 layers of those 6 blocks. So I can think about this as being volume equals big B multiplied by H. Volume equals 6 units squared multiplied by 7 units, and volume is going to give me 7 times 6, 42, and then we're stuck with determining what number of units or what label we put on that. So we know it's units, and then we go back up and look at our base area, and we have that imaginary one next to our regular unit. So we're going to say, oh, well, that's 1, 2, 3, or think back to the cube. There would be 42 unit cubes in this particular figure. This diagram's taken away the idea of having those unit cubes, except for we can still think about having a base layer. And that base layer would be our length and our width. It's going to give us the base layer and our height. So we just look at the diagram to the left and we determine that we would see our base layer having dimensions with a length of 8 and a width of 4. So I know that 8 times 4 gives me 32 inches squared, multiplied by the height, which is 7. And it's completely okay to use a calculator. I'll do the same thing off the screen. So 32 multiplied by 7 is 224 units, and inches cubed, because we would think about this having a big enough volume to hold 224 cubes in this prism. At this point, you're realizing that every time we go to find the volume of a shape or of a figure, I keep going back to volume equals length multiplied by width multiplied by height. And we can think about that as that base area represented by big B multiplied by the height. So for this rectangular prism, you would start by writing on your paper those 2 rules, or at least one of them, to show me what you're looking to solve for, not just chicken scratch or math scratch, so to speak. And I'm going to substitute in what I know. So I know that the length is 14, I know that my width is 3, and I know that my height is 4. So then I'm going to go ahead and show the work. Again, showing the work means simply the process, or those steps, becoming more simple. 14 times 3 is 42, multiplied by 4. So the volume of this rectangular prism would give us 168. And since there is no label over here, we're going to pretend or imagine that those are all units. And so we're going to label our answer with units. And at this point, everybody should be screaming units cubed for our unit label with volume. My plan is to be able to use some unit cubes in class in the next couple of days for us to be able to build and understand length, width, and height and what the orientation would look like, but then also to be able to answer the question of the number of cubes in this column for each of these prisms, and then using the volume formula to calculate the volume, where we use length times width multiplied by the height. So stay tuned, we'll do this in class. We'll also talk about prisms that do not have a quadrilateral for a base. And you just need to keep in mind that as long as you find the area of the base, or that big B, then you would still be able to find the volume. So volume here is still big B multiplied by H, keeping in mind that the area of your base would be 1/2 multiplied by the base of the triangle and then multiply by the height inside that triangle before you finally multiply by the height of the prism. And so for a quick show of this, this big B is really going to be 1/2 little b times the h, and that's all part of this triangle. And then multiplied by the height, which would be the height of the prism. So in starting with a triangular prism again, if I draw a triangle prism, it's going to have rectangular faces and that triangular base. The triangular prism is more difficult for us to draw. Okay, I'm going to keep in mind that I need to know the base of my triangle, so I'm going to use that top triangle kind of to discuss the base, and then the height of the triangle, allowing for us then to also have the height of the prism. So we're going to do volume equals big B multiplied by h, where big B is equal to 1/2 the base of the triangle, the height of the triangle, multiplied by the height of the prism. That's really important to remember. It's the height of the prism. And this here is the, just kind of keep in mind the triangle. So let's put some numbers to this. And if our numbers are, let's say, 6 for the height and 3 and 4, then my rule becomes volume equals 1/2 multiplied by base 3, height 4, multiplied by 6 as our height of the prism. And of course, the other way we could look at that would be to simply go back to a different color. Let's do, I guess, red. And we could also say that that's volume equals 3 multiplied by 4 divided by 2 for the area of your triangle, the area of the base, multiplied by 6. And you should still get the same thing. 3 times 4 is 12, divided by 2 is 6, 6 times 6 is 36. So we would have 36 units cubed for our volume of this triangular prism. So just to review, when we're finding volume, we always label our answer with cubic units. So that looks like inches cubed, feet cubed, units cubed, etc. And volume can be most easily represented by doing the area of the base multiplied by the height. I hope this video has been helpful and look forward to helping each one of you in class.